Hello, Mr. Wilford here. I just want to go through Chapter 7, Section 4 with you, Properties of Logarithms. In the last section, we started talking about logarithms and what they are. We talked about the definition of logarithms. Hopefully you're able to go from log form to exponential form to log form, back and forth, and kind of get used to using logarithms a little bit. In this section, we talk about some properties of logarithms. So just like anything in math, we need properties, we need rules that we can kind of follow. And there are three basic properties that we're going to start out with. There's something called the sum of logarithms, and it looks like this right here. It actually is if you have two separate logarithms, two terms with separate logarithms, but you have the same bases, and you're adding those two logarithms, you can actually combine them into one single logarithm. And what you would do is multiply whatever is in the m place here times whatever's in the n place here. And you can also go in reverse. You could start with something like this, a single logarithm, and break it apart into two separate terms. The example here shows, it says express as a single logarithm and then simplify if possible. So we start out with two separate logarithms and we're adding them, the sum, and we want to multiply 2 times 32. We combine them into one single logarithm. So 32 times 2 is 64. So we end up with a single logarithm, log base 4 of 64. Again, the way that you do this is you think base 4, so 4 to what power will give me 64? And if you use a calculator, whatever, you find out that it's 3. 4 to the third power will give you 64. Then you have a difference of logarithms, and this works kind of the same way. You have two separate logarithms. This time, however, you're subtracting them, and so to combine them into one single logarithm, you would divide them. So you divide the m divided by the n, and that's what it looks like as one single logarithm. Here's an example, log base 2 of 32 minus log base 2 of 4. We would write it as one single logarithm by taking 32 divided by 4. We get 8. So then again, you think 2 to what power will give me 8? Well, 2 to the third power will give me 8. And so our answer here is 3. Our third property here is the power of logs. And this one we'll use quite a bit. The way it works is like this: log base b of a to the power of p. Basically what you're doing is you're taking this power p and you're going to bring it down in front of the logarithm, and you would multiply p times log base b of a. And here are a couple of examples that kind of show that using that. Log base 3 of 81 squared. This power of 2 here comes down in front, and then you figure out what log base 3 of 81 is. Okay, if you look over here, log base 3 of 81 is 4, because 3 to the fourth power is 81. 4 times 2 is 8. Same thing goes over here. We bring the 3 down in front. Log base 5 of 1/5 is -1. -1 times 3 is -3. Now, another thing that I mentioned last section, is that calculators will do base 10. You can do base 10 on your calculator, and you can do logarithms with base 10. Now, if you have a logarithm of a different base, you actually can use your calculator with that as well. And it's called the change of base formula, and it's kind of a nice formula because you can figure out with the calculator what log base 4 of 8 is. The way that you would do this is you would bring the 8 up on top and the 4 on the bottom, and you change the base. Now in this example they changed the base to 2, but it makes sense if you're going to use your calculator to follow this example here and bring the 8 up, bring the 4 down, and now you can see that these are both base 10 because we don't have a base number, so we assume they're base 10. Now grab a calculator, plug in log 8 divided by log 4, and you get these numbers here. You do the division and you get 1.5. Again, just be careful that you're plugging things into your calculator correctly. If you have any questions, please let me know. Thanks.